I'm at the beach and I'm in the ocean and I'm eye level with the ocean horizon, I want you to picture that you're eye level with the surface of the Australian continent.
Yep.
And what we're actually doing is peering down. Hi, and welcome to Wonder, the Planet Earth podcast for curious people. I'm Holly Cook, joined as always by fellow Earth scientist Dr. Anthony Reid. Now, we have actually had a stack of really fantastic geologists, geoscientists come in. You'll notice our last 7 or 8 episodes are actually conversations where we have these really geological, scientific, right in the weeds of it convos. And we need to come up for air again, Anthony. We've had some fantastic explorations of I want to say, sure, it's Australian geology, but really it's understanding how this country and its natural blocks and its landscapes, what it even means to say, how did Australia come together? That's where we've been playing. So that's what you can expect of this episode, is just come on the journey with Anthony and I as we come up for air and try and figure out what exactly has been said to us over these last few episodes. Something we wanted to do before that, though, is say a big fat g'day to our brand new tsunami of subscribers that we've had over the last few weeks. It's fantastic to have you along on the journey. It's been lovely getting to know you all too. The comments you've been leaving have been really, really splendid actually to sort of engage with. What have you thought of our new community, Anthony?
Oh, it's wonderful that it's starting to build and there's more and more people connecting with what we're trying to do here. It makes it gives me a lot of encouragement to keep sharing what we're sharing. Obviously, we're striking a chord with some people at least, and that's wonderful. So thanks for everyone for joining along in the ride, and thanks for you, Holly, for
going on Nick Zentner.
Nick Zender for supporting and his comments were very encouraging. He's such a lovely guy, and it's just super inspiring to hear his reflection on, and isn't it crazy how the algorithm works, right?
Yeah.
There's him just probably late at night scrolling or whatever, listening to whatever he's interested in. And then I was just picturing, him sitting there and, oh God, and another geology podcast. Do you know what I mean?
Yeah.
Like the sort of, sometimes you're not perhaps as inspired to look into your own area of interest.
Yeah,
You've probably got other things. Yeah, you've got other areas, things that you're mainly interested in, perhaps other than your kind of professional area. But he clicked on it, and obviously something clicked for him. And so hopefully that continues for other people. So thanks, Nick, for getting on board.
I think what would be nice to do is, given that podcast interview that I did with Nick, sort of, it was so well received, I think it would be a nice opportunity to reintroduce ourselves. Like we sort of did this 2 years ago when we kicked this whole thing off, but I've also grown as a person in the last 2 years. And Anthony, I would like to give you
I've got a lot more grey hairs over this side of the table, that's for sure.
Grey hairs and stress. That's what years have given me. So Anthony, what would you like to share about yourself with our new friends?
Oh, that's great. Well, I say I'm Anthony Reid. I am a South Australian. I was thinking, that I'm Australian, but within Australia there are
You pronounce your words right within.
I'm not saying right, but we pronounce it. So for the classic South Australian thing is we would say school with the long O, school, more of a school sound. Whereas in the eastern states, you'll hear them say things like school
and pule
and tool and things like this. I mean, they
love you.
pronounce it differently, but there's subtle regional variations in accent. But I'm very much a South Australian. The Reid family arrived in Adelaide in the early days of the colony in the 1860s, and I often drive past the area where the Reid family had a tannery. This is the Reid kind of original, the OG tannery, not there anymore, but there still is a Reid Street, I think it is, in that part of the city.
Oh my God.
Right next to the River Torrens here. So anyway, so I feel very connected in some sense, very connected to this place, South Australia here. So for those people who don't know that there is a South Australia, there is a South Australia. It's kind of in Central Australia, really, Central Southern Australia.
Yeah.
But that's where I'm connected to geologically, and professionally I'm a geologist. But I'm not really a specialist in the way, say, an academic would be in a particular kind of discipline of geology, and that's really because I spent my life working in a geological survey, a government geological organisation, and in that situation, you're forced to generally work across a whole range of, geological terrains and geological processes. So I worked on really young rocks and sediments, and I've worked on the really, really old rocks and, gneisses and granites and these things like this as well. So I feel like I got a big, broad kind of range of geological process as a result of working in such a fantastic environment in a geological survey. Yeah, and now I do work for Fleet Space Technologies, who do mineral exploration related geoscience, and it's absolutely incredible journey that we're on. So maybe we can talk about that another time. But
Wow.
I'm having a lot of fun in that company as well. So we're doing a lot of interesting, geophysics and lots of seismics and magnetotellurics and all these sort of geophysical ways of interrogating the Earth. And so it's just been great to be able to come on the show and come away from that specific sort of application of geology and just enjoy and embrace my love and enthusiasm for geoscience. That's really a little bit about me, I guess you'd say. What about you, Holly? What keeps you coming back to the podcast and away from your day-to-day?
Yeah, away from everything else I should be doing. It's sort of like I get a lot of enjoyment out of ping-ponging between ideas. So as I explained on Nick Zender's podcast, I'm actually coming up to a hard deadline. Like my first year of my PhD is about to come to a close, and it's been a fantastic journey. But before then, well, if I go actually like chronologically back, I spent some time in the Australian minerals industry. Even though I hadn't graduated university yet, I was fortunate enough to be welcomed into a team. I learnt a lot there. Before then, I was still my earth science graduate, like I was in my earth sciences undergrad, and I started uni by doing physics. I failed every physics class I took, but I met my partner who I love. So, I mean, there's silver linings and everything. But, right back as a kid, I grew up on these fantastic and really heartfelt ideas of what science meant to people. I couldn't separate what it means to understand, it means to know, it means to connect. And knowledge is something that we build and tinker with. And ultimately we use it. Well, I like to use it to help me understand what this great big thing is called life. And so that's ultimately what keeps me coming back to the studio. As I know it sounds a bit macro and faffy, but like I said to Nick, there is an obligation we have as knowledge builders, as scientists, to share that curiosity and especially about the Earth, right? Because I think that this human moment on our planet is an immense one. And if what we can do is spark conversations, and you and I aren't afraid to say, I don't know.
Oh, I'm saying it constantly, actually. So.
And so the human moment needs to be full of a bit more, let's interrogate that, or I'm not sure, or who can we talk to, or what ideas can we talk about? And if in this studio and on this podcast we can actually just have these really robust and fascinating conversations grounded in the Earth and how people on the Earth work, then I'm doing my job here.
You're here for it.
Yeah, I'm here for it.
You're a genuinely curious scientist, and one of the things that I've reflected on in listening back to a couple of these last few episodes that have been put out on the Wonder podcast has been how much we've deliberately tried not to use jargon words and kind of really intense scientific words, but they inevitably
they creep in.
They do, and they have to. They have to. But it does always create a barrier to the kind of, if you, and this is why, I didn't even attempt physics at university, I've got to say.
Just data physicist instead. That's right.
I've got a few questions for locking myself, actually. So, but anyway, because once if you miss a little bit at the start, it becomes very tricky to catch up, So I do hope that people who are listening are, if there are things that people miss, just, get in touch, pop questions. And we've had a few things like that where people said, we'd love to see a map and this type of stuff. So, I feel like part of our job here is to give people something that's interesting, give people something that engages them but stretches their knowledge a bit, but not too far so that it breaks.
Correct.
So,
Correct. It's dancing that line of tension between going, okay, so if you're curious, then it means you don't know something. And if you don't know something, then what you have to do is be prepared to feel a little like, oh, this is like new and it's stretching me. But that's what learning is. That's what I find it fun.
Yeah. I too, totally. Yeah, I'm here for the learning, that's for sure.
Yeah, and on your point, Anthony, when we've had feedback over the last couple episodes in the comments, that's literally what we're going to base this next conversation on. And, we will actually also get to Pangea and Gondwana, but what you guys have been telling us as listeners is go get out a map and just circle some stuff and point some stuff out. Because when we have these conversations, we just throw around things like 4.5 billion years, Sydney to Perth, 300 kilometres beneath the surface. These are ridiculous things to try and visualise. So we took a screenshot of the Australian continent on Google Earth.
High tech here on the Wonder podcast.
And what we're going to do is basically try and synthesize what we now understand about the geology of this beautiful country. Anthony, you have an iPad in front of you. We're hooked up to a screen.
I do.
What have you got to say for yourself?
Well, so yeah, I thought let's just go right back. We had Professor Pete Betts from Monash Uni on a few weeks ago, and he gave us an amazing description of some of the kind of terrains and the processes related to that. And Sabine Zahirovic talked recently as well about the whole movement of the entire continent. But the interesting thing that Pete talked about is that the continent's made up of a mosaic of other bits and pieces, I guess, which were fragments of previous big continents as well. So let's just have a quick look at Geology 101, of the not. I'm not going to talk about the sand or the soils or the sediment sitting on top. I'm talking about the sort of crystalline rocks, the granites, the gneisses, these type of thing, which make up the deeper roots of the Australian continent. So I just thought I'd circle a few things.
Completely, and it's a funny tension that we're going to introduce because we're looking at a bird's eye view of the continent. But what I'm mentally doing is actually almost as if I'm eye level. Like if I'm at the beach and I'm in the ocean and I'm eye level with the ocean horizon, I want you to picture that you're eye level with the surface of the Australian continent.
Yep.
And what we're actually doing is peering down
a little bit and just skimming away across.
Yeah.
So if you looked at that sort of level, what do you see? So let's start with where some of the oldest rocks are in Australia.
We have some old stuff.
With some really old rocks, and they're mostly in Western Australia, which is very well known for this region I'm circling here. I hope you can see it. It's sort of a circular little fragment. And there's a town about here, roughly there, which is called Marble Bar, famous for being the hottest town in Australia.
Hot town, cold beers.
So this area is called the Pilbara. This is the Pilbara Craton, roughly. That's roughly when the age of the rocks in here go from way back to about 3.8 billion. And some of the area, 3.8 billion, you can see enormous sort of structures in this region. And there's also a huge area through roughly about there. Sorry to anyone who knows anything about it, but roughly about there. There's a whole lot of other, in the central bit there are a whole lot of iron-rich rocks, these iron formations, from which huge amount of, iron ore is exported from Australia from this region. The sort of, huge buildings which we see in the modern skyscrapers and that sort of stuff largely start out in part from iron ore mined in this part of Western Australia in the Pilbara Craton. So south of that, there's another huge area, which again, roughly speaking, is sort of like this, not exactly like that, but something like that. This is called the Yilgarn. I should probably write up the Yilgarn. And this one goes from about 3.3, a little bit younger, to 2.6. So these two terrains make up probably like the oldest bits of the Australian continent, really. This is where the oldest rocks are. In fact, there's an area somewhere in the middle part of the Yilgarn, I think it's roughly there, which is called the Jack Hills, and this is where they have these super old mineral grains going back to about 4.4 billion. So everybody loves the really, really old stuff, okay? But this is where the really, really old stuff is in Australia. So that's kind of like, when we talk about the western third of the ancient part of the continent, that's roughly where it is, okay? Now, I'm going to change colours, and now I'm going to show you kind of what we talk about as the middle kind of regions of Australia, and it goes roughly from up here in the Kimberley, up roughly like this. There's a whole area which runs all the way down here.
Get me to the Kimberley.
There's so good up there. And there's another region out through Mount Isa and a little bit popping up somewhere up through there. So all this were the Kimberley, the Central Australian regions, which we call the Arunta. There's a place up here called the Pine Creek. There's the Mount Isa. There's lots of terrains up here. All of these have very similar, not identical, but similar and related geological terrains. And they roughly extend from about 2.5 or maybe a little bit older, 2.6, down to about 1.6 billion or so.
Wow.
Like roughly, this is kind of in that Earth's middle age is represented very well by these terrains up here. So if you take a drive, as I have, and I'd love to do, all the way up here along what's called the Stuart Highway from Alice Springs in Central Australia to Darwin, you'll cross across some of these amazing terrains. It's a wonderful drive and really see part of the continent. In the southern part of Australia, we have a similarly aged bits of crust which kind of look a bit like that, which is also a sort of about, 2.5 to about 1.6. However, interestingly, if you go to I can tell you this story very well because I was part of it. If you go to about where I've circled there on the Northern Eyre Peninsula, there's a rock which is 3.15 billion. And that is the kind of little bit of a window into the deeper parts of the entire continent. So there's really, really ancient stuff underneath even that. Now, the next part of it is the other third of Australian continent, and that roughly runs. Well, it's not blue.
Give us the blue.
Give me the blue. There, it runs in a line, kind of like that. This is not perfect, but it's roughly like that. And it's all of this gear out here,
Right.
which Peter Betts talked about as the Tasmanides. These are the younger rocks that sit on top of something, sit out to the east, I should say.
Mm-hmm.
And this area here there's some rocks which go back to, say, I don't know, about a billion or so, but most of them are about 500 million years or younger.
Mm.
And they extend all the way out to, when you're down in Sydney and you see what Sabine talked about, the Hawkesbury sandstone out here in Sydney, you've got all the sediments of volcanics of Victoria and New South Wales and Queensland up there as well. So roughly, when we divide Australia into three macroscopic geological terrains, you've got super ancient, middle-aged, and then younger. That's what we were trying to show when we talked with Peter Betts.
Yeah, completely. And, keeping in mind that convo with Pete, what we then saw with Sabine is, before I go into the specifics of what we saw with Sabine, what you ultimately saw was continents looking like they're literally just floating across the globe. And so it's not like Australia's been static, just waiting for this moment in 2025 to look how it does. This is it's made up of blocks that themselves sort of floated around the globe and had things smashed onto them, and they were pulled apart and volcanoes erupted up through them. Like, talking about a dynamic Earth, right? This continent that we live on archives some of the most ridiculous spans across the globe, like through supercontinents, through snowballs, through some of the most dramatic things that could happen to a blue planet.
It's crazy, yeah.
It's archived in our rocks.
It is. And I think let's pick up on that in the sense that, well, for example, in Western Australia, I drew a line around the Pilbara and I drew a line around the Yilgarn, and they're not connected. So people might well ask, well, what's going on in this region out?
In the in-between.
In the West, what's the in-between? Oh, and they are really complicated bits of rock, okay?
Anthony's looking at me going,
cut. I mean, they're complicated bits of rock. I mean, even those terrains within the Yilgarn, within the Pilbara, within North Australia, they're complicated bits of rock because they are bits of rock which have been sutured and amalgamated through various types of processes. But then you look at those bits which are then amalgamated to each other, and they also amalgamated for various types of processes. So picture something like bits of Indonesia. There's big kind of continental ribbons and bits and pieces of continental crust separated by oceans, and they're being pushed and moved and kind of colliding with each other in through that kind of whole central Southeast Asian region, Borneo and Sumatra and everything. In a few million years, you could visualize scrunching them all up, and then you would have a bit of Java right next to the sort of Malay Peninsula. But there might be kind of a little bit of folded up sedimentary rock collected and caught up between the two. So this is the sort of processes which happened in the ancient past of Australian continent, and there's great examples of that through the central part here, where there are entire terrains through the central part here, where there are entire terrains of kind of like ribbons of ancient continents and magmatic arcs and sort of processes which were collected together between these two in the process of bringing these big continental fragments together.
Yeah.
So that's within the one continent, right?
Yeah.
But then what happened was we started talking about these even bigger things, which is like Gondwana and Pangea and stuff like that. So probably we should also do a bit of a...
I completely want to get to the supercontinents. One episode, though, that this also reminds me of is Dr. Isra Izzad, who came on from the ARC Centre on Critical Resources for the Future. She is my experimental petrology idol over at University of Western Australia. And what Isra spoke about a lot, and please go listen to that episode. It's just, it's a really, it's quite dense, but that is some real geology happening there. It's fantastic. Anyway, point is, if we're at the cross section, we're at eye level with the Australian continent, then I want us to go like hundreds of kilometres below into the mantle. And what you and I bang on about a lot, or at least I do, is, and I'm wearing the green mantle minerals on my wrist here. The mantle is meant to be green, it's solid and it's green. That's like the punchline at a party. Did you know that the mantle is solid rock and it's green? Isra comes on and tells us, there are places where it's not always green. There are places where the mantle is patchy. And that's because when you melt it, when you sort of overlay these tectonic happenings and you sort of look at the way that the mantle responds and it melts and it reacts, those melts react, and it creates these patchy marble cake-like dark sides of the mantle. And that story is important for how endowed our continent is with mineral resources. So these are episodes that travel not just on the surface, like not just through mulga trees with Steve Hill, not just cratons with Carolyn Eakin or with Pete Betts, but actually then into the deep mantle with Isra. And that's just it's a really cool journey. So
yeah, it's so good. It's so good. And connecting that was our discussion with Carolyn Eakin
from Australian National University.
From ANU. And that was, again, looking at the deep structure of the Australian continent and the fact that, the roots of it go down a couple of hundred or maybe 300 kilometres. And there's actually, and although the surface has a sort of a relatively flat expression, if you were to go down a few hundred kilometres to it, underneath this continent, you'd see that there are kind of lobes and kind of deeper bits and shallower bits. And as you said, the composition of that mantle would be different. It's quite a complicated place down there.
Oh, yeah. And I lost my mind when she said it the first time, and I loved it again when I went back and listened to it. But to think about the topography of the cratons, like these are, why have I got an image of like a mandarin in my head? It's like they're not just rectangles floating on the surface of the earth. They're bulbous things with roots that are eroded, and like there is immense topography. Like, who cares about Mount Everest? Get me to whatever mountain is at the bottom of the get me to the mountain at the bottom of the Yilgarn.
Perhaps let's not throw away Mount Everest.
Yeah, true.
Such haste, but
true. I'm
appreciate
talking a lot for someone who'll never have to scale the mountain on the underside of the lithosphere.
I watched an incredible documentary about Lakpa Sherpa. I don't know if you've seen her on Netflix.
I've seen it around, yeah.
Oh my goodness, she scaled Everest 10 times. She's a Sherpa from the Mount Everest region. Anyway, that's a total distraction, but she's an incredible person. I mean, her journey is quite spectacular in terms of coming back from adversity.
Awesome. Well, that's your Wonder for the Week recommendation.
Oh, my goodness. Yeah, I was blown away. Yeah, 10 times up the mountain. Yeah, wow. So anyway, but we can do sort of like...
Well, the mountain we're going to now climb is actually trying to synthesize what Sabine walked us through with these supercontinents. So to anyone who actually knows anything about G-plates, you'll know I'm about to butcher this software. So I'm just going to need you to enjoy the ride. And for those of you who watched our episodes with Sabine Zahirovic, we previously with Andrew Meredith, we spoke about Gondwana. And then we fast forwarded with Sabine and we started talking about Pangea. So Anthony, I'm looking at, for those who are following along on video, I'm looking at the globe and I'm looking at it in the present day. It looks fairly familiar to me. What I would like to do is take you back to Gondwana. I'm thinking, should 550 do the trick?
Yep.
Rightio.
So about 550 million years ago.
Wicked.
So there was a huge amalgamation of continents. So 550 million years ago or so.
Ish.
It didn't happen all at once. And again, like I was talking about those bits of amalgamation which formed the Australian continent, there in Gondwana we see a whole lot of strings of continental kind of zones which are indicative of collision. So you've got metamorphic rocks, you've got kind of big scale structures, you've got kind of collections of rocks which shouldn't be together, put together by faults. And these are some of the indicators which help us piece together these ancient continents. Yeah. Yeah. So we have a feature there. So what are we looking at, Holly?
Well, we are just looking at this big continent, and in particular, I think that we're focused over the sort of the South Pole, right? So something I found interesting is to think about the different latitudes of these supercontinents. Like they're not just always, well, in fact, I don't know why I said they're not just always. I don't think they have ever really just been simple things that are sitting at the center of everything. These can be concentrated over different like latitudes of the planet, and that means something for what the climate does, for what the flora, actually I say flora, were plants around? There were, because what I like to think about with Gondwana is how the distribution of different types of plants on the planet today are scattered around different continents all over the place. And it only makes sense if you actually rewind the clock and can see the lump of land like this and go, yeah, okay, well, that could have just been one continuous biome, or like that could have just been one continuous place where this flora and fauna existed. And once you scatter the continents because of the power of plate tectonics, yeah, okay, those Gondwanan plants will be now scattered all over as remnants in the modern world. What I struggled with, because we're not afraid of saying what we struggle with in science on this podcast, is if I then fast forward to kind of around Pangean times,
So what time have you got to now?
I'm kind of at 260.
Yep. So that's about when, Pangea was started to amalgamate about 300 or 330 million years ago.
Okay.
And really started to break up from about both of them started to break up. The whole thing started to break up from about 180 or 200 million years. But yeah.
Right. And what you just said, the both of them, this is my point, which is I didn't really see like a massive dispersal. I sometimes talk about a pulse, and maybe my own language has fooled me because I didn't see like Gondwana explode and then come back together.
Yeah.
In fact, I just sort of saw a casual drift, and next minute, I think that's like North America is smashed on the end, and you have this behemoth landmass that is near global. It's almost like this C-shaped thing that is spanning from the north to the South Pole, and it has a lot.
You could have walked from the North Pole to the South Pole. So you can see in the images that Holly's showing us, you can see the red is North America. You've got the green is what's called Baltica, and so together there's a Laurentian landmass, and then as you go further south, you can see Africa and South America. Incredibly, the similarity of those coastlines is just phenomenal.
It's unbelievable, and it's worth actually saying out loud, right? But I think we glossed over it with Sabine. But when you do look at I think every kid in like year 3 probably looked at the map and discovered plate tectonics. And when you look at those coastlines, you go, oh, what are they doing looking so similar?
I know.
Well, it's not really a coincidence.
Well, until you had a process to describe why that was like that, I guess probably the old timers did go, that's really suspicious, but there was no
guts of an explanation.
No explanation. But now we know it's actually the deep mantle processes which have pulled those two things apart. Yeah, incredible. Then you go further south, you can see the Antarctic continent, which was connected both through to India, north of it there, and the Indian subcontinent, and the Australian continent there as well. So, yeah, that together, that kind of amalgamation is referred to as Pangea. It's extended from about 300, as we said, about 330 to about a couple of 100 million years ago when it started to break apart.
And I can really see the modern world in that. Maybe it's just because the colours of today's continents
the colours the colours definitely draw your eye. I think if you could take off those colours and have a look at it, you'd see a whole bunch of mountain ranges and a whole bunch of huge river valleys. You'd see big inland ocean areas of inland ocean. Oh, there you go. Yeah, that's beautiful.
So what I have is actually it's a paleogeography map, and I think it's overlaid with some kind of topography. So exactly what Anthony's saying is that we can actually, and maybe we should get Professor Alan Collins back in, because what you can actually start to do is talk about the enormous Earth-defining features that would have existed on these supercontinents, like the massive mountain ranges from the collisions that brought these things together. And even if you cast your minds back to our episode with Alan Collins, probably I think it was last year, where he spoke about, do these big supercontinental mountain ranges have anything to do with how life or like complex life came about, or the immense sedimentation that would have just fluxed into the oceans as these big mountain chains eroded? These are, it's very pretty to look at an amalgamation of continents. It is even cooler to think about what those sort of invisible, smaller scale processes or effects that they have on the world around them, what that also meant for developing the modern world, right?
Totally.
Well, look, on that, Anthony, I really do think it's been a fantastic ride with these last few guests. What we should have also released by the time that this comes out is an episode with Mark Tingay, where we actually go through a really intense story of where geological field expeditions can take you. We'll have an episode with Ross Chandler, who is also in the Centre and Critical Resources for the Future, talk us through what mineral exploration and discovery looks like on the Australian continent. So we have an awesome catalogue yet to come for you guys.
More work coming, and thanks to the Geological Society of Australia in particular for supporting our little efforts here. It's been wonderful to have them back it, and we very much appreciate their support and the support of everyone else who's contributing likes and subscribes and all these things, which helps keep this thing going, propelling. So thanks.
Completely.
Thanks, Holly.
Big shout out to the GSA for supporting it. It's been an immense amount of help. You can find us on Instagram at the GeoCo. We have a website, geoco.com.au. Please find a way to get in touch. Leave us comments. Let us know what your questions are. This is something that we hopefully, well, even today, it's been shaped by what your questions have been, what your curiosity has been. So please do get in touch with us. Find us on our socials. And until then, we'll see you next time,
rock
Anthony.
On. Yeah.
Rock on.
See ya, Holly.
See ya.